Now the third module, that is the network optimization principle. That is also we will discuss the network problem troubleshooting, in which we will discuss the SS blocking, call blocked, or we can say, and second troubleshooting, call drop. Troubleshooting the call drop and troubleshooting the call block. In this module, we will discuss. This slide shows the network optimization principle, how we optimize our mobile network, GSM mobile network. So we start from the single site verification. That means we go on the site and verify the antenna cable, whether it is a tight or loose, what is the tilt of the antenna, what is the orientation of the antenna, whether it is a cable swap is there between sector A and sector B or not, whether it is a sector swap or it is a cable swap is there. All this verification actually we have to done on the site only. Okay, so first we have done site verification, where the azimuth angle, with the help of your compass, na, you should measure the whether is on the A sector is on the 0 degree, 10 degree, 20 degree, like that. We verify and correct the data in that cell file also. Next point comes in the RF optimization part, right? We take the drive test and identify the problems, right? And after the identify the problems, and we can optimize, we will optimize in third step the parameter, whether it is a handover parameter or neighbor parameter, we should optimize in the BSC. We can change all those parameter, power parameter, frequency parameter, right? And after that, making the changing the parameter, check whether the requirement is meet or not. If the requirement is meet, that means the optimization is done. Is not mean, this process is again repeating, right? So focus on basically better coverage and better interference control, and also the optimization, uh, parameter optimization basically focus on the performance and user experience. Right. So this one is just a network optimization procedure. After site verification, RF optimization or drive test. After taking drive test, analyze the drive test file, then parameter optimize in the BSC and check whether it is a meet your requirement or not. The single step process. Now, in this module, we will discuss the blocked call troubleshooting and drop calls troubleshooting. So first we will discuss the block call troubleshooting, what are the regions and what are the solutions for blocked call. The block calls can occur due to SS failure and HGCCH congestion, right? And HGCCH drop and TCH congestion. All the call blocks may be due to all these reasons. And troubleshooting of this cause, maybe we can troubleshoot by seeing the layer 3 messages in the drive test. We will see some of the snapshot of layer 3 messages, how can recognize there is a blocked call, whether it is SS failure or TCH congestion is there, right? And also note the parameter of maximum retransmission channel configuration, right? And BSAGs, BLS, KS. This is actually AGBLK in the Ericsson system, and in the Nokia there is a BSAGBLK reserve for AGCH blocked, right? These are the some parameter actually in the CCH configuration. We can note that parameter and we can verify that. The block call analysis, actually the block call may be due to different reasons, due to paging failure, due to SS failure, due to SGCCH block, due to TCH block. So due to paging failure, paging actually it is a message, always originates from the MSC. Paging message always originates from the MSC and sent to all the BSC in the location area of that MSC page. The BSC will then calculate the paging group of the mobile station and send a paging command to the BTS controlling the location area of that MSC. On the air interface, there are two causes of paging failure. Either the mobile receives no paging message, or it receives a paging message but it is not able to respond, or you can say it is not able to decode that message, right? Which could be due to error in paging message or poor radio quality. These are the some reasons to paging failure. Next is the SS failure. SS failure means the irrespective of the purpose for any communication required with the network, a mobile sends a channel request on the RACH. Right? First, if you want to communicate with the network, you have to transmit the random access channel, RACH. What you are requesting? You are requesting for the SGCCH channel. This is the signaling channel used in the GSM network. Standalone dedicated control channel. Right? We have already discussed this is the dedicated control channel, that is the standalone dedicated control channel. And wait for some time for response, which should come from the BTS on an SS grant channel. For a response always comes on the SS grant channel. A mobile will do several retransmission of RACH, that is predefined max retransmission. One parameter I have seen there in the previous slide, there is a max retransmission. That max retransmission is predefined, right? And if it is still does not get a response, it goes back to idle mode. That is the SS failure. Because we are assessing the system network, and after predefined retransmission, if there is no response from the base station, that means your mobile goes to the in the idle mode, back in the idle mode. Next block calls troubleshooting is the SGCCH block. Right? Once a mobile has sent a channel request on the RACH, and it expects a response from the BTS on the SGCH. This should be immediate assignment command to an SGCH. If you send the request, if the response comes, that means it is an immediate assignment command comes on the SGCH to an SGCH. And this immediate assignment reject comes instead when the SGCH blocking is there. Right? If SGCH blocking is there, which message comes in layer 3 messaging, that is the immediate assignment reject. If the SGCH receive, its command is there, immediate assignment command is there, then next blocking is maybe occurs due to TCH block. Right? TCH block means after the completion of call setup signaling, a mobile expect assignment command to a TCH so that speech can commence. If no assignment occurs for a specific period and mobile has to return to idle mode, then it is due to TCH congestion. So there are different block calls troubleshooting. First one, we start from the paging failure, then SS failure, then SGCH block, then TCH block. This is actually a sequence, the signaling sequence from paging to TCH block, right? All these are the blocking scenario. You can see here also layer 3 messages, 3 scenario. In scenario 1, there is a maximum retransmission parameter is there. This is the SS failure. Basically, we are sending RACH request, channel request again and again. How many times? That is the maximum retransmission parameter times. and there is no response from the network. That means it is successful. These are messages actually we can see in the L3 messages or layer 3 messages in the TEMS drive test tool or Nemo drive test tool. Second case where channel request is there, right, from user equipment, and immediate assignment reject is there. That means request is reaching to the base station, but the response is negative response is there. That is the immediate assignment reject. That means it is a SDCCH blocked. This parameter actually we can see in the dive test actually. And third scenario where the TCH block, channel request is there, right? And after channel request, your response is there, immediate assignment is there. That means you are getting the SDCCH channel. After the getting the SDCCH channel, the signaling is there between the UE and base station. And after signaling, all the signaling completed. If there is no TCH assignment, mobile returns to idle mode. These types of scenario, after this signaling, now all the signaling completed, and then your mobile comes to the idle mode. It is the case of traffic channel blocked, right? Block calls cause troubleshooting, basically the SS failure, right? SS failure, I have seen you are sending the RACH and there is no response from the base station. That case is due to uplink interference or common control channel overload, low RX level at the base station, right? Base station TRX decoder malfunctioning. If there is a fault in the TRX, the SS failure may occurs, right? Coverage hole is there. If there is coverage hole, and downlink interference and access cell range means you are assessing the UE from a very large distance. So these are the some reasons for SS failure. These types of, you can see here, these types of messages actually are there in the layer 3 messages. You can see channel request, channel request. RR means radio resource channel request, radio resource channel. How many times they are sending the channel request? Maximum number of retransmission. That is the parameter, na? Channel configuration parameter, where the max retransmission is given there. Na? That number of times they are requesting again and again, right? The phone back to idle mode. That means after channel requesting, it comes on the system information one. This is the broadcast information, na? BCH information. That means our phone comes in the idle. That means there is a SS failure. Clear? Now cause of the this SS failure, AGCH, there may be uplink problem, na? Downlink and uplink, poor uplink quality, BTS receiver problem. Actually, I have already discussed in the previous slides. AGCH overload at the base station means SS grant channel. That means there is no SS grant channel available. Yeah, overload is there. Ne? That means you are not able to send the immediate assignment command. That's why one of the region of SS failure. Now, second one is if there is a uplink problem, not different scenario in the SS failure. When there is an uplink problem identification, you can see here you are sending the channel request, right? That there is a paging request type 1, immediate assignment, you are getting immediate assignment, then system information type 3 comes, and then again you are sending the channel request, immediate assignment comes, immediate assignment extended, then again paging request type 1. That means it is a type of blocked call, na? You are getting the immediate assignment, right? You are getting the immediate assignment, but your signaling is not done on the HSCCH channel. These types of channel requests and getting the immediate assignment, and there is again comes on the system information 3. That means you are getting comes into the idle mode. Your phone mobile station comes at the idle mode. This one is the SS failure due to AGCH overload. There is a one parameter na AGBLK. How many resource block you reserve for the SS grant channel? That parameter is the AGBLK. So that you can note that parameter and see the layer 3 messages where channel request is there, immediate assignment extended, then again you are sending the channel request. And this types of repeated command, multiple immediate assignments seen after channel request, that means there is a AGCH overloading in there. 3-4 times you are saying na? Immediate assignment extended. That means there is a overloading, AGCH overloading. And this AGCH overloading you can optimize by changing the AGBLK parameter, or you can say AG underscore BLKS underscore RES. This one the different parameter, na? In different vendor they are using their different name for that parameter. So how you can optimize this 5 OMC data for the same period of the following stats: number of successful RACH BG counts, number of RACH with invalid establishment cause. These are the number of deletion actually for analyzing the OMC data for this root cause analysis AGCH overloading. You can see this. Okay, block call analysis now. AGCH congestion due to different interference and higher location update is there, and at the boundary of the lag boundary, right? Heavy traffic. These are the different reasons for AGCH congestion cause. Because in the location update and all these interference and heavy traffic cases, heavy SMS traffic cases where AGCH congestion is there. In that case, the AGCH congestion can cause the block call. Now, third one is the TCH block causes. That is the interference. Verify the idle channel interference report from the OMCR. If suspected, carry out uplink interference measurement. And also heavy traffic, verify the traffic channel holding time and no attempt statistic from OMCR. Okay, then you during the low traffic hours activate cell barring in the cell, or you can convert the full rate to half rate to increase the channel resources. Also solution to the block also is the optimized coverage and also optimize cell loading. We will discuss how we optimize the cell loading. Dynamic half rate allocation, we can optimize this parameter so that dynamically they convert the full rate into half rate channels. Dynamic half rate full rate mode adaptation, parameter settings in the BSC for reducing the HSSH blocking. These are in the OMCR. When some of the region hardware problem, configuration problem, one timer is there, that is the T3212 timer, that is the periodic location update timer. When this timer value is very low, in that case a frequent location update is there. In the frequent location update, HGCCH channel they are using there is a loading of HGCCH is increased, and that case if your timer value is low, so what you will do? You will increase that timer value. The unit of T3212 in the deci hour. Its value from 1, 2, 3 like that. And 1 unit is equal to 6 minutes. Normally T3212 periodic location update timer we are setting in our BSC, that is the 4 hours, or we can say 40 value. Now after block call troubleshooting. We are discussing the dropped call troubleshooting. The call drops actually are identified through the one of the region is the through the SAT message decoding. Na? When we are decoding the SAT message, we can see here the 26th frame multi-frame and 12th frame as a SAT frame, na? SAT burst. So by decoding that SAT message, we can identify the region of drop region, call drop region. So a radio link failure counter value is always broadcast on the broadcast channel. RLT timer. We can also see the RLT timer current value and maximum value in the drive test radio parameter. Na? At the establishment of dedicated channel, the counter is set to the broadcast value. The mobile decrements the counter by 1 for every unrecoverable block of data detected on the SAT. Right, decrement by 1 if there is a unrecoverable block of data, and incremented by 2 if every block of data that is correctly received. If this counter, RLT timer counter, radio link timeout reaches 0, a radio link failure is declared by the mobile and it returns back to the idle. If the counter reaches 0 when the mobile is on the HGCH, then it is a HGCH drop. If it is happens on the TCH, then it is a TCH drop, traffic channel drop. So one of the radio link failure counter is there that shows the when it reaches the 0, then the mobile automatically declare as a radio link failure. This radio link failure message also comes in the layer 3 message, as you can see when log files during the log file analysis. The drop call analysis, we can see here the 3 cases: TCS drop, HGCS drop, and handover failure drop. Channel request, you can see here, na? Channel request is there, and after channel request, there is an immediate assignment in layer 3 messages. Then again, service request is there. After the signaling, RLT0, RLT0 means radio link timeout becomes 0, counter becomes 0, then drops declared by the mobile station, and it is a HGCS drop because there is no traffic channel allocated till now. In the second scenario, after the signaling, you can see here the traffic channel is allocated to the users, and then your radio link timer out na, it becomes 0, counter becomes 0, and drop occurs. That means it is a TCS drop. This RLT value actually na, you can see in the drive test box radio parameter. Right? And third scenario is the handover failure drop. So HGCH, TCH handover command is there when from one base station to other base station, and the hand access is there. If there is a failure is there, na handover command is assigned, but there is a handover failure in between, call may be dropped. So drop call analysis, region, cause, the HGCS drop cause is the coverage, interference, multipath, BTS performance. TCH drops causes is the coverage, interference, multipath, BTS performance, and preemptions. Handover failure due to some threshold parameter, handover margins, and missing neighbors. These are the some regions of drop call analysis. What are the solutions of TCH drop, HGCH drop? Actually, handover failure is also a region of for drop. Na? The solution to drop calls is the optimized coverage. We should optimize the coverage, and interference. We can plan the frequency, BCCH frequency, so that the interference is minimized, and also optimize the neighbors. No? Suitable neighbors is there between source and target, and optimize also handover parameter. Effective frequency hopping is there. You plan proper HSN and MIO so that there no interference in the TCH eruption, and also use the DTX and power control in uplink and downlink so that interference can be minimized. These are the some solutions by using the you can reduce the call drop. This one is the flow chart by which we can see the how we can troubleshooting the drop call. Right, drop call scenario, whether it is due to radio link failure or RLT timeout. Yes or no. If there is a yes due to RLT timer, right? We go next. If there is no, na handover attempted, handover failed. If no, then the layer 3 analysis. We can see a wide drop call is there. If yes, we can see the RX quality if more than 4. Yes. Then we can see the RX level, right? If they, we actually identifying there is a problem of RX signal level, poor signal level or poor quality, right? So we can, if there is no, that means there is a uplink problem. If quality is not more than 4, that means it is a uplink problem. If RX level is less than -95, then it is a coverage problem. So we can identify by using this flow chart whether it is a uplink quality problem or there is a RX level problem, coverage hole is there. If all these are, there is no uplink problem and coverage hole problem, then we can see the TCH and PCH, there is a co-channel interference, whether it is a co-channel interference, multipath interference or adjacent channel interference by using the different parameter, na, C by I. If less than 9, that means it is a co-channel interference. In C by A, other parameter where we can see the, if less than 9, that means it is a adjacent channel interference. So we can identify all these uplink problem, coverage hole, co-channel interference or adjacent channel interference by using this flowchart. And all these parameter, actually RLT, RX quality, RX level, and C by I, right? C by A, all these parameters are in your drive test window, radio parameter. Thank you for listening me.